Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the mechanism behind every AI agent you've heard about. Tool calling. And the first surprise is that the model never actually runs any code. Not once.
That can't be right. People say the model searched the web or queried the database. If it doesn't run code, who does?
You do. Your code does. Here's the gap it's filling. A language model can't reliably do math, doesn't know today's date, and has no clue what's in your database. The fix isn't a cleverer prompt. It's handing it tools. And a tool call is nothing more exotic than the model emitting a structured JSON object that says, I'd like to run get weather with city equals Tokyo. It asks. Your code runs the real function and feeds the answer back.
So this is just the structured output idea from before with something wrapped around it.
Exactly. It's structured output with a loop around it. Walk the loop with me. Turn 1. You tell the model here are your tools and pass the user's question. The model replies, not with prose, but with a structured call. Get weather, city Tokyo. You run that function. Get back 18 degrees. You append that result to the conversation and call the model again. Now it writes the human sentence. It's 18 degrees in Tokyo. Predict, execute, feedback, finish.
There's a detail I always trip on. When my code sends the tool's result back, what role does that message have? My code produced it, but it's not the assistant talking.
Beautiful question, because it confuses everyone. The result goes back in as a user message. Even though your code, not a human, produced it. It just is how the model's role-based view of the conversation works. The assistant made the tool call, so the answer to that call arrives as a user turn. And crucially, the model sees its own earlier tool call sitting in the context, which is exactly why its final answer can refer back to what it asked for.
And every framework, LangChain, whatever, is really just this loop.
Just this loop with bookkeeping. Different providers dress it in different words. Anthropic calls it tool use. OpenAI calls it function calling. There's MCP as an open standard. But the contract is identical everywhere. JSON schema in, a structured tool call out, the execution result back in. Learn it once, and the rest read fluently.
You can also force the model's hand here, right? Make it use a tool whether it wants to or not.
There's a tool choice knob. Default is auto. The model decides if a tool is even needed. You can set any, meaning it must call some tool. Or you can force one specific tool by name. And that, by the way, is exactly the structured output trick for Claude. Force call a tool whose input schema is the shape you want. Or none to block tools and demand plain text. Default to auto. Reach for the rest only to override.
What about SPIDE? If a user asks for the weather in Tokyo and Lagos, does it have to go one at a time?
No. And this is a real latency when people leave on the table. A modern model can emit to tool calls in a single turn. You run them both, ideally in parallel, and send both results back in one message, each tagged with its own call ID. If the API handed you parallel calls, don't process them in a sequential loop. That's just throwing away free speed.
Now the part that scares me about agents, the loop running away, the model calling the same tool forever.
It's the classic failure, and the fix is one line. Always cap the loop. 5 to 10 iterations is typical. Models do sometimes get stuck calling the same tool over and over, or bouncing between tools that converge nowhere. An uncapped loop just burns money and never returns. And log every call and every result. That log is how you debug an agent's bad day later.
What about when the tool itself blows up? My function raises an exception in production.
Don't let it crash and don't hide it. Catch it and return the error as the tool result. Literally, error. City not found as structured data. Then the model decides, retry with different arguments, give up gracefully, or ask the user. Same with bad arguments. The model passes a string where you wanted a number, schema validation catches it, you hand the error back, and the model usually self-corrects. Hiding the failure just leaves it confused.
Here's what worries me most. The model is deciding what to run. What stops it from doing something destructive? Deleting a record it shouldn't?
This is the line you do not cross. Never wire a model directly to a destructive action without a guardrail. Delete user account must become model proposes deletion. A human or a rule approves. Then it executes. And the deep reason is the scary one. A tool call is untested input to your system. Models can be jailbroken, confused, or prompt injected through the very documents they retrieve. The web page it just read could be telling it to delete things.
So poison document is essentially a command injection into your agent.
You just name the threat model exactly. Make safe reads obvious. Gate every write behind approval. And treat the model's intent as a suggestion to be checked. Never a command to be obeyed. Good tools help too. One job per tool, descriptive names, and field docs like you're writing for an underspecified intern. And return structured results, not loose sentences.
So the one sentence to keep.
The model only ever asks. Your code decides and runs. It emits a structured request. You execute, you feed the result back, and you guard the dangerous ones, because that request is untested input. That's the Datarekha audio guide. See you in the next one.